ओके आज हम डिस्कस करने जा रहे हैं सैंपल डिस्ट्रीब्यूशन फॉर द डिफरेंस बिटवीन टू सैंपल प्रोपोर्शन एंड देयर प्रॉपर्टीज। तो ये तो ऑलरेडी हमने डिस्कस कर लिया है कि व्हाट इज सैंपल डिस्ट्रीब्यूशन फॉर P1 हेड माइनस P2 हेड। आज हम इनकी प्रॉपर्टीज डिस्कस करते हैं। फर्स्ट प्रॉपर्टी इज अबाउट द मीन। इफ यू वांट टू कैलकुलेट मीन फॉर द सैंपल डिस्ट्रीब्यूशन ऑफ P1 हेड माइनस P2 head, it is denoted by mu P1 head minus P2 head, and it is always equal to the difference between the population proportions. And if you want to verify this, you can calculate the left hand side and you can calculate the right hand side for this equality. The left hand side can be calculated by summation P1 head minus P2 head time probability of P1 head minus P2 head. And the right hand side is P1 is given by x1 divided by n1, P2 is given by x2 divided by n2, where x1 is odd number in the population 1 and n1 is the population 1 size, and so as the second population. The second property is variance of the sample distribution for the difference between two sample proportion is denoted by sigma square P1 head minus P2 head, and it is equal to P1 Q1 divided by N1 plus P2 Q2 divided by N2. This is for infinite population, or you can call it sampling with replacement, where Q1 is equal to 1 minus P1 and Q2 is equal to 1 minus P2. Similarly, in case of sampling without replacement, or you can say in case of finite population, variance of the sample distribution of P1 head minus P2 head, this is equal to finite population correction factor of population 1 into P1 Q1 divided by N1 plus finite population correction factor for population 2 into P2 Q2 divided by N2. If you want to verify the left and right hand side, again you can verify it. The left hand side can be calculated by P1 head minus P2 head square time probability of P1 head minus P2 head minus P1 head minus P2 head time probability of P1 head minus P2 head whole square. You can calculate the left hand side by this formula, and the right hand side, this is the formula for P1, this is for Q1, and this is N1. Similarly, P2, Q2 and divided by N2. This is the case of sampling with replacement. In case of sampling without replacement, you can also include the finite population correction factors conditionally. What are the conditions? You can calculate sample as the percentage of population. This formula is sample is the percentage of population. Sample from population 1 divided by population 1 size multiplied by 100. You will get a value. If this value is less than 5, you can skip the finite population correction factor, this one. Similarly, you can calculate sample as the percentage of population. Sample size from the population 2, this is population 2 size. Calculate it, multiply with 100 and look at the value. If this is less than 5, you can also skip the finite population correction factor from population 2. So this is we will verify this left hand side and the right hand side in the subsequent topic. Alright, third property is in case of proportions, the populations are normally are binomially distributed. However, if the sample sizes are greater than 30, then sampling distribution of P1 head minus P2 head will be normally distributed, and this is nothing else, this is the central limit theorem. And last property is standard form of the sampling distribution for the difference between two sample proportion is given by difference between sample proportion minus mean of the sampling distribution of the difference between proportion and standard deviation of it. Using this formula, you can standardize any difference of sample proportion, and you can quite easily find the desired probabilities. So all these are the properties of the sampling distribution for the difference between two sample proportions.